All right, ladies, this is the second video going through your Surds and Indices test solutions. So I must warn you, my dog, I'm upstairs, and at this time of night she likes to bark at possums. So if she starts getting too loud, I might have to stop, but let's see how we go. Okay, question 14. So here we have an base of x. So sorry, I'm just doing question 14. Base of x to the power of 3, and then that's to the power of 4, and then that's to the power of 5. Now, when we're doing powers to the power, they are multiplied. So basically what we're going to have here is 3 times 4 times 5. So 3 times 4 is 12, and then 12 times 5 is 60. So your answer is x to the power of 60. Question 15, we have 3a plus 1, 3 to the power of a plus 1, sorry, equals 27. Now, when we're solving for powers, so say our unknown is a power or an index, we need to get on the left-hand side and the right-hand side the same bases. So 3 can't actually change. So let's change to the 27. So 27 is actually the same as 3 to the power of 3. And a little clue is, well, if this side's 3, this side has to be 3. So you've got to say, well, 3 to the power of what gives me 27? 3 to the power of 3. So 3 times 3 times 3 gives you 27. Okay, so now that we have the same bases, we just let the powers equal each other. So a plus 1 is equal to 3, and then we just solve for a. So we subtract 1 from both sides, disappears. A is equal to 2. Nice. Okay, question 16. Express using positive indices. All right, let me just rewrite it. So we've got a half, a to the power of 4, b to the negative 7, c to the negative 3. Now, you can just identify your negative indices first. This is positive. 4 is positive. Then we've got negative 7. And here we have negative 3. So your index law, let's leave that half there. Actually, I might just rewrite that. Okay, so I'm going to do a big fraction. Okay, I'm going to start off with a half. The a, because it's already a positive power, doesn't change. So it's a to the power of 4 stays on the top. Now b to the negative 7 is on the top, but if we want to bring it to a positive power, we take it to the bottom as b to the power of 7. And then the same for c. So c to the power of 3. Now let's just tidy things up. So we've got a to the power of 4, 2b, 7, c, 3. Okay, let's move on to question 17. Okay, express in simplest form using positive indices. So again, let's just rewrite it. Now, questions like this and skills like this, you just need to take your time. Okay, you don't want to make little mistakes. You probably know what you're doing. We're just dealing with a lot of numbers. So we're just going to make sure we don't make mistakes with the numbers. Okay, so what I would do first, instead of just putting, so we've got a to the negative 1 here. Before making that a positive power, I'm just going to deal with this power out of the brackets. Okay, so this 2 means that this power is multiplied by 2, and this is multiplied by 2, but this 2 is also, which is 2 to the power of 1, is also multiplied by 2. And then in the other bracket, this 2 is the power of negative 3, and b is b to the power of 1 is multiplied by negative 3. So a bit tricky on that front. Okay, so let's just do each part by itself. Okay, so 2, it's to the power of 1. 1 times 2 is 2. Then let's do a. A to the power of negative 1. Negative 1 times 2 is negative 2. Then b, 3 times 2 is 6. Let's move on to the other one. So we've got a to the power of 2. So we've got 2 times negative 3 is negative 6. And then b to the power of 1. 1 times negative 3 is negative 3. Now we can bring them together. Okay, so let's not shift anything just yet. Let's just do this multiplication. So 2 squared is 4, and 4 times 4 is 16. Then we've got a to the negative 2. When we're multiplying, we add our powers. So it's going to be plus negative 6. And then we do our other base, which is b. b to the power of 6 plus negative 3. Now, I don't have another page, so I'm just going to put it over here. So 16a. So negative 2 plus negative 6 is negative 8. Sorry, I'm just looking at the answer. And then b, negative 3. I just want to make sure I'm on the right track. Okay, good. Now, let's write it as a fraction. Okay, so 16 is on the top. Then we've got a to the negative 8. So we could leave a to the negative 8 on the top, but if it goes down the bottom, because we want it to be a positive power, it becomes a to the positive 8. And then the same for b. So b to the power of 3. So if it was to stay on the numerator, that would be negative powers, but when they come down, they become positive. And if they were ever to be negative on the bottom, you bring them up the top as positive. Okay, so going to just grab another page. Might grab a few pages. Okay, scroll. And then scroll here. We're up to 18. Okay, so tricky again. So let's just take our time. 5x negative 3, y to the negative 4 times 6x negative 1, y to the power of 8. Now, let's bring everything together first before we start shifting our negative powers. So you've got this 5 and this 6. So 5 times 6 is 30. Then we've got x. So x is to the power of negative 3, and we have also a negative 1. So when we're multiplying, we add the powers. And then we've got y to the power of, might circle that as well, negative 4 here and an 8 here. So we're going to have negative 4 plus 8. All right, so let's just tidy up a bit. 30x negative 3 plus negative 1 is negative 4. Y negative 4 plus 8 is 4. So that's going to simplify as, now, before I race ahead, and don't like how that comes up. Okay. Oops. There we go. All right, so we're going to have our fraction. So the 30 is on the top. Now we've got x to the negative 4. So think of this as a fraction. This is all over 1. Yeah, and I've got to change it. So this x to the negative 4 is a positive power. At the moment, it's a negative power, so I bring it down to the denominator as a positive power. This y is already positive, so it stays. Okay, so it's 30y to the power of 4 over x to the power of 4. Okay, let's zoom. Question 19. We have 32 to the negative, eyesight, 3. That's a terrible 3. What have we got? 3 over 5, I'm assuming. Now, this is tricky because you have a rational index, okay, so a power that's a fraction, and you have a negative sign. So how annoying is that? So let's just rewrite this first. So whenever you have a rational index, it's always a good idea to rewrite it. Now, there's 2 ways you can rewrite it. We can rewrite it as 32 to the power of, it doesn't really matter where you put your negative sign. Actually, what I might do, I might just erase that. Okay, I'm going to deal with this negative sign first. That negative just means it's 1 over 32 to the power of 3 over 5. Okay, so negative just makes it 1 over. Basically, this is 32 over 1. We're just flipping it. Now, this 32, I can rewrite as 32 to the power of 3 to the power of a fifth, or I can rewrite it as 32 to the power of a fifth, or cubed. Because when I multiply these powers, either way, I get 3 over 5. Now, you've got to ask yourself, and this is a hard question you've got to ask yourself, what is easier for me? 32 cubed? 32 squared would be hard, let alone 32 cubed, or 32 to the power of a fifth. Now, this one, a lot easier. Now, you might think, oh, but to the power of a fraction? That just means 32 to the power of a fifth is just what number multiplied by itself 5 times gives you 32. Okay, so I'm just going to rewrite it here. So 32 to the power of a fifth is the same as the fifth root, all cubed. So this just means what number multiplied by itself 5 times gives you 32, and that number is 2. So the fifth root of 32, or 32 to a power of a fifth, which are the same things, is just 2. And then we've got 2 to the power of 3, so that's going to be 2 cubed is 8. So your answer is 1 over 8. All right, just give me a bit more space. We're up to question 20. So we've got 10 to the power of x equals square root of 10. Now this is where you have to rewrite this surd, square root of 10, as an index. So square root is the same as the power of a half, because this is the second root, or 2 root. Okay, but we just don't write it like that. Okay, so then it's to the power of a half. Now your bases are the same, so x is equal to a half. So, nice short question. All right, question 21. Oh, I feel like this is going to be shorter than the previous video. 64 to the power of 1 negative 1/3. All right, as I said before, this negative sign, 64 is basically 64 over 1. So we're going to rewrite that as 1 over 64. Okay, just to allow for that negative sign, and then we'll deal with this 1/3. So I'll put the 1/3 up here. Now this is the same as the cubed root of 64. So the power of a third is the same as a cubed root. So you've got to ask yourself, well, what number multiplied by itself 3 times gives me 64? So you've got to go through all the numbers. It's not 2, because 2 cubed is 8. 3 cubed is 27. 4 cubed, so I know 4 squared is 16. And then 16 times 4, awesome. So your answer is 4, so 1/4. Okay, so knowing your square numbers or your cubes to power of 4, etc. Okay, question 22. Got 4 to the power of x plus 1, 2 to the power of 3x. Now, as I said before, your bases have to be the same. So 4 is the same as 2 squared. Just like 9 is the same as 3 squared. Just had a blank. 16 is the same as 4 squared, and so on. Okay. Now I rewrite that 4. Instead of writing 4, I write 2 squared. Same thing. I haven't changed anything. I've just made it look different, but it is the same. And then I've got x plus 1. Now the reason I did that is because when I'm solving powers, I need the same base. Okay, so now I've got 2 on both sides. So I'm just going to expand this bracket first. Now the reason I put it in brackets is so I remember to do both the x and the 1. So it's 2 times x, which is 2x, and then 2 times 1, which is 2. And then on the right-hand side, I've got 2 to the power of 3x. Now, just scroll, scroll, scroll. Now that I have the same bases, I let my powers equal each other. And then I just solve for x. So I've got 3x on this side, 2x on that side, so I'm going to subtract 2x from this side. Otherwise, if I bring that 3x over, I'm going to end up with a negative number. So I've got 2 equals 3x minus 2x is x. If you like, you can rewrite that as x equals 2. All right, question 23, scroll, scroll, scroll. Oh, do I need another page? Already. Okay, I might just get another page because I don't want to get carried away. Can't do 2 pages. Okay, scroll, come on. I bet you're a blank. Oh, no, you're not a blank page. Okay, so where are we up to? Question 23. Let's try to keep it under 20 minutes. So y equals 5 to the power of negative x. And we want to find the coordinates when x is equal to 2. Now, this is very similar to a linear equation. What we would do if we wanted to find the y coordinate, we just substitute in x equals 2. So here's 2, here's x. So what we do is we have y equals 5 to the power of negative 2. Okay, so the negative sign's already there. We're just inserting the 2 instead of having the x. I don't know why I drew that in red, but anyway, there's a dog. Can you hear it? Okay, so 5 to the power of negative 2. Negative sign, okay, remember that's 5 over 1. So we flip it, take the inverse, and then it's squared. So we can't forget that squared. So 1 over 25. Now it is asking for the coordinates. So any coordinates on a graph, it's xy. We already know x is 2, and our y is 1 over 25. Okay, so there's your answer. All right, question 24. Nearly there. Y equals a to the power of x passes through 364. Now, just like a linear equation, we're just substituting in here. This is x, and this is y. So wherever I see y, I put in 64. And wherever I see x, I put in 3. So 64 equals a to the power of 3. Now, you got to say, well, if this is a to the power of 3, what number? So a to the power of 3 is the same as a times a times a. So what number, when multiplied by itself 3 times, gives you 64? So we did this before. 2 cubed is 8, 3 cubed is 27, 4 cubed, 64. So your answer is going to be 4 to the power of 3. So your value of a is 4. All right, last question. This one is very similar. Okay, it's just on a graph. And it's just got to fill in the blank. So it's got y equals square to the power of x. Now, usually we use the letter k. Okay, so you might see in the future it's k. Sometimes you will see a. So in the previous one we used a. So I'm just going to use a again. Okay, but it can be anything. If your favorite letter is q, it can be q to the power of x. It's just a letter that represents some number, and that number we need to work out. So I'm going to use this just because the previous question used it. So we've got y equals a to the power of x. The point we're substituting in is 1, 3. Okay, so remember, this is a point where the coordinates are x, y. So wherever I see y, I'm putting in the number 3. And a just stays a because that's what we're solving for, and x is 1. Now, any number to the power of 1 is just that number. So 1 to the power of 1 is 1. 2 to the power of 1 is 1. 3 to the power of 1 is 1. Oh, sorry. Oops. It's 2. 3 to the power of 1 is 3. Oh gosh, how embarrassing. 4 to the power of 1 is 4, and so on. So that means a to the power of 1 is just a. So your answer there is a equals 3. Okay, so next page. Oh, I thought we only had 25 questions. 30 questions. Okay, that's all good. Definitely not going to finish under 20 minutes. Okay. I'm just going to make this bigger so I can see the question. Okay, which of these options can be used to rationalize the denominator? So we've got 1 over root 5 plus root 2. So this is one of the hardest questions on here because you're very likely and you're very used to multiplying it by whatever that denominator is. So we've got root 5. Oh, I can see at my window a possum. Exactly what my dog is barking at. Okay, so we're so used to, oh, there she is. She's seen it. Okay, so we're so used to multiplying it by the same thing. But if you remember back to year 9, when you expand a binomial, which is, this is effectively, you're not going to get, I don't know how to explain this without actually doing the question. Okay, I might do that over here. So if I was to do root 5 plus root 2 times root 5 plus root 2, okay, and when we're expanding that, we've got root 5 times root 5, which is the square root of 25, root 5 times root 2, which is root 10, and then we've got another root 10, and then we've got square root of 4. So what we've got now is 5 plus 2 root 10 plus 2. So effectively, we're not getting rid of this surd. Okay, we've still got a surd here. Now, what you need to do, oh, here she is. She's, when I say she, my dog. You're right, you're barking at the possums. Okay, let's just rewrite it again. Okay, so what we need to do is multiply that by root 5 minus root 2, and that'll cancel out that middle term. Okay, and I will show you in a sec because I'll do this multiplication. So that's your answer, B, but I'll just show you because I showed you before, root 5 plus root 2 times root 5 minus root 2. So root 5 times root 5, square root of 25. Root 5 times root 2, negative root 2 is negative root 10. Root 2 times 5 is positive root 10. And root 2 minus root 2 is minus root, is 0. Oopsies. Okay, so, oh no, we're multiplying. What am I doing? Sorry. Can you tell I am rushing? I don't know why I did that. Root 2 times root 2, okay, so there's a negative sign there, is root 4. All right, square root of 25 is 5. Root 10 plus root 10, they cancel each other out. And then we've got minus root 4, which is just 2. Okay, so you can see there that on our denominator, we now have the number 3, which you didn't have to do. You only had to do the start of it. Okay, question 27. Okay, so another rationalizing the denominator. So we've got root 8 minus root 6 over root 3. So here, just a single term. So we're multiplying by root 3 over root 3. So on the denominator, root 3 times root 3 is just 3. And then you have to just do this numerator. So root 3 times root 8 is the square root of 24. And then root 3 times root 6 is root 18. That's all over 3. And then we just need to simplify. So I'm going to cut corners here. I'm not going to put every single step in. The square root of 24, the highest square number that goes into that is 4. So it's 4 times 6, so that's going to give me 2 root 6. And then 18, what's the highest one that goes in that? 9. So it's going to be 3 root 2 over 3. So your answer for that one is D. All right, question 28. Do I need another page? It's going to be another page. There we go. Okay, so rationalizing the denominator again. 3 root 7. So we're multiplying just a single term on the bottom. So we've got 3 root 7 over 3. rushing. I was rushing. 3 root 7 over 3 root 7. Okay, so on the bottom, we're going to have 7 times root 7 is root 49. So it's just 7. And then on the top, we've got 4 root 8 times 3 root 7. Okay, so I'm going to just multiply the number in front of the square root. So 4 times 3 is 12. And then we can do the 8 and the 7. So 8 times 7 is 56. And that's over 21. Okay, the highest square number that goes into 56 is, I don't know, 4 does? 4 times, oh, is that 4? Let me just check. So 4 times 10, 14? Okay, I just had to look at the answer to double check. Okay, so that's 12. Square root of 4 is 2, and then we've got root 14 over 21. So 12 times 2 is 24, root 14 over 21. And then we've got the highest common factor of 24 and 21. So we're just going to simplify that. So that's going to be 3. So 3 goes into 24 8 times. And 3 goes into 21 7 times. I think I just found an error with that question. Did I? I might just have to double check. Let me just double check on my calculator. Oops. All right, I realized where I went wrong and I thought, well, I could rewind and show you, but I'm going to just do it now. And I don't know whether you picked up. I hope you would. What mistake I did do is I missed this 3 times 3. So it's probably a good idea for me to show you this because we all make mistakes. So 3 times 3, so this should be a 9. Okay, and 9 times 7, making our denominator 63. So 9 times 7 is 63. So that's 63. That's 63. That's 63. And that means that this becomes 21. So I'm kind of glad that it was a multiple choice question because if I got that wrong in a test, I would be like, well, either I've made a mistake or the test is wrong. And it's more likely that I'm wrong. So good idea to go back through your answers and just see where you made that error. And I did cheat and check on the calculator because sometimes the test is wrong. All right, question 29, nearly there. Simplify. Okay, so I'm going to just write that down. But we've got 35 over 24. Now this isn't actually as hard as it seems. Okay, so let's just do this one separately. So we've got this 35 over 7. So I'm going to just redraw my fraction. 7 goes into 35 5 times. So I can just put the 5 up there. So we're basically simplifying that. And now we've got root 24 over 12. Now this part here can be rewritten as square root of 24 over root 12. Whoops. No, I can't. I'm getting distracted. 24 over 12, which is 2. So instead of writing square root of 24, simplifying that, simplifying the square root of 12, you can put both under one square root sign. So put the whole fraction under one square root sign. And now we're left with 5 root 2. Okay, question 30. That's our very last question. Okay, let's see if I need any space. Okay, so we've got an exponential curve it is y equals 2 to the power of x, which graph shows the curve reflected in the y-axis. So basically, we've only got two choices here. If you think about the graph being reflected, so kind of like a mirror, if we were to put the mirror along the x-axis, it's going to basically be a mirror image of itself. So anything on, and I can't touch this because it'll probably not like it, but on this left-hand side, whatever is there gets put on the right-hand side, and whatever is on this right-hand side gets put on this left-hand side. So it's reflected along the y-axis. This one here is reflected along both by the looks of it, reflected along the x-axis and the y-axis. Okay, so your answer is A. All right, girls, well done. Yeah, bye-bye.